Hi, I'm Miss Hearn. Let's get started. In this video, we're going to look at an example of a real-world isomorphism. But before we dive into that, let's look at some vocabulary we're going to be using in this video. First of all, two graphs are isomorphic if they indicate the same pattern of connections between the same number of objects. Essentially, we use the word isomorphic to indicate two graphs are really the same graph. There's a correspondence between the vertices of isomorphic graphs, such that any adjacent pair in one graph corresponds to an adjacent pair in the other graph. A listing of this correspondence between the vertices identifies what we call an isomorphism between the graphs. For example, let's look at graph X and graph Y. When we're analyzing graphs to see that they are isomorphic or not, one of the characteristics we'll look at is the degrees of the vertices. So I'm going to go ahead and throw the degrees on here. Notice that each graph has 3 vertices of degree 2, a vertex of degree 1, and a vertex of degree 3. So besides the fact that they have the same number of vertices, they also have the same number of vertices of the same degree. Another indication that we have a pair of isomorphic graphs is that they both have cyclic subgraphs of the same size. Each of them has a triangle, a 3-cycle within it, and no other cyclic subgraphs. You can also tell visually that if we were to flip this graph over vertically, that we would have that triangle on the bottom and then 2 edges coming off the top, just like we have in graph X. Remember, the position of the vertices isn't important, only which vertices are connected. But to help us see the isomorphism, I'm going to draw a picture with F and G at the bottom. And then F and G are connected to K, which is connected to H, which is connected to J. That might help us see the correspondence even more clearly between the two graphs. This is just another version of graph Y. We see we have that vertex of degree 1, and then the vertex of degree 2, vertex of degree 3, and 2 vertices of degree 2 down here. So it looks like we could make a correspondence between E and J, between D and H. D is connected to B and H is connected to K, so we could make a correspondence between B and K. And then we actually have 2 options here. B is connected to C of degree 2 and B is connected to A of degree 2. And K is connected to 2 vertices of degree 2 as well. So it doesn't matter which one we associate. We'll go with C being associated with F, and we'll go with A being associated with G. So this correspondence defines an isomorphism between the two. I also could have said E matches up with J, D matches up with H, B matches up with K, C matches up with G, and A matches up with F. And we still would have retained the connections as well as the degrees of the vertices being the same. Either one of these is an isomorphism between graph X and graph Y. Now let's see how we can identify isomorphisms in a real-world scenario. Remember, an isomorphism is saying that we have the same connections between the same number of objects. So here I have the business structure, the hierarchy in 2 companies, company A and company B. The graphs of the structures look a bit different, but part of that is just in the design and how it's being presented. So we're going to simplify this so that we're not distracted by the design. We're going to simplify each one by creating a graph that represents it. Let's start with company A. I've assigned a label to each of the departments in company A, and I'm going to use those labels as the vertices of a graph. I've listed the vertices off to the right, and now I'm just going to go vertex by vertex and connect them to each other as they're connected in the graph. So A is connected to B, there's an edge between A and C. B is adjacent to D as well as to E. C is adjacent to F as well as to I. D is adjacent to G and E is adjacent to H. Now let's look at company B. Once again, we've labeled all of the departments, and we're going to use those as our vertices. And I've drawn the vertices off to the side, and we're going to connect them. A and B are adjacent, as well as A and G. B and C are adjacent, as well as B and E. C is adjacent to D, E is adjacent to F, and G is adjacent to both H and I. Now let's put them side by side. I'm starting to see a similarity in the structures. For one thing, there are no cycles in either of the graphs. Let's look at the degrees of the vertices to see if we can get a better idea. So in each case, we have 3 vertices of degree 2. We have 2 vertices of degree 3. And we have 4 vertices of degree 1. So not only do we have the same number of vertices, but also the same number of vertices of a particular degree. Now, if we're looking to see if we have an isomorphism, those things that we've observed are definitely an indication that it's possible, but you have to set up the isomorphism to prove that you have one. So some things to look for. First of all, I notice little patterns in the numbers. For example, here, A, B, and C, we have 2 vertices of degree 3 and then one in between them of degree 2. And I see that same pattern here. And there are no other vertices of degree 3 anywhere else on the graphs. So it looks like we could match capital A with lowercase a, and we could match capital B with lowercase g, and we could match capital C with lowercase b. Now let's look at another structure that stands out to me, which is there's only one place where we have a vertex of degree 3 that has 2 vertices of degree 1 coming off of it. The other vertex of degree 3 has 2 vertices of degree 2 coming off of it. So looking over at company B, we have the same thing. Here we have 1 vertex of degree 3 with 2 vertices of degree 1 coming off of it. And up here we have a vertex of degree 3 with 2 vertices of degree 2 coming off of it. Alright, so let's start with the part that's circled in blue on each graph. Alright, so now we have a little bit of a problem because I matched up capital B with lowercase g and capital C with lowercase b. Notice that C really matches up better with G. All of these are degree 3s, but the structure that they're attached to has to be the same in each graph. So I'm going to back up and switch that around. So capital B should be matched up with lowercase b, and capital C should be matched up with little g. Then we could let capital F match up with lowercase h, and capital I match up with lowercase I, and that would finish off what I have circled in blue. Now let's address the part that's in green. So in green, we see capital B match with little b, which we already have listed here. Those are the vertices of degree 3. Coming off of those, we have each 2 branches in each graph. Capital D, capital G branch. And then corresponding to it, we have either really one of the EF or the CD branches. Because in either case, we have degree 2 and then degree 1, degree 2 and then degree 1. I'm just going to go ahead and pick to match capital D up with lowercase c and capital G up with the vertex attached to lowercase c, which is lowercase d. So I have one branch taken care of over here, and now we do the other branch. So capital E, I'll match up with lowercase e, and then adjacent to that, capital H must match up with lowercase f. Okay, so at this point we've gone through all of the vertices and matched them up, and we've defined an isomorphism. So what does that tell us about our original company structures? So they have the same underlying structures. Even though they looked different, they have the same underlying structure. Now, does that mean that they have the same departments? No, a lot of them are the same. For example, we have the CEO and the CEO. The CEO is looking over the Chief Financial Officer and the Chief Operating Officer, which is very similar to over here where they're supervising the Financial Director and the Director of Operations. Okay, so far this is pretty similar. Now let's look at what the Chief Operating Officer is in charge of. Operations and production. That corresponded to the Director of Operations. They're in charge of distribution and acquisition. So there's a slight difference here. Apparently the company A is maybe has a factory and they're actually creating product, whereas maybe in company B what they're doing is they're acquiring products to then sell. So there's a little bit of a difference in what they're actually doing, but the underlying structure is the same. And then let's go to the financial officer and the financial director. The financial officer is in charge of HR and accounting. And over here we have the financial directors in charge of the employment office and bookkeeping, very similar. And then human resources at company A is in charge of recruitment. The office of employment at company B is in charge of hiring. And then accounting is in charge of inventory. And over here, bookkeeping is in charge of inventory. And we actually see this a lot in the structures of companies. A lot of them are very similar in their structure. In this case, exactly the same. In fact, isomorphic. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.